Okay, so the final video I'm going to do on binomial and calculator use is just this particular question. So it's looking at these questions where we've got these constraints of 5% of the time. So it's almost like unwinding the binomial and figuring out what you need to put in to get 0.05 or 5% back. And there's a couple of ways of thinking about that. So a factory produces a component for the motor trade, and 5% of the components are defective. A quality control officer regularly inspects a random sample of 50. Find the probability that the next sample contains fewer than 2 and then more than 5. So the first thing I want to do is to write down what I want my model to be. So firstly, I want to know what x is. So x in this case is my random variable. I want this to be the number of defects. Technically, it's the number of defects within this given sample, which is of 50. Because I'm lazy, I'm not going to put that last little bit though. And the model here is x is modeled binomially with n being 50, and the probability of defect is 0.05. This is my model that I'll be using. Part A, fewer than 2. So remember, fewer than 2 doesn't include 2. So it's less than 2. So the first thing we want to do to be able to calculate this is to rewrite that with less than or equal to. So x is less than or equal to 1 in this case. So fewer than 2 is either 1 or 0. Again, I just go into my calculator. I don't want the PD, I want CD because I want more than 1. And on this one, I'm just going to put in again, I'm just going to put in the 1 and then all the other bits of detail. So 50 and 0.05. Don't know why I keep doing that. Too fast for it. There we go. So I get an answer. Let's do another equals 0.27943 ... So that's the very first one. So in other words, 0.2794. What we're doing here, it is, I don't know what this is. It's just components, isn't it? So there's a 0.2794 defects, I suppose. Question B is more than 5. So it needs to be just strictly greater than 5, not equal to. So greater than 5 means I want it to be 6, 7, 8, 9, all the way up to 50. So I basically want everything. So remember, everything is 1, but I don't want 0, 1, 2, 3, or 4. So I need to remove 0, 1, 2, 3, or 4. So that's everything that's equal to or less than 4. Again, I can put this in my calculator. So this is going to be 1 minus, and I'm just going to put 4 into here, which is 0.89638 ... A quick trick for when you're doing 1 minus. If you want to do this fast or quickly, obviously it's going to be 0 point, but if you add, make sure every number here adds to 9, apart from the last one. That'll be your kind of 1 minus whatever that is. So 8 plus 1 is 9, so it's going to be a 1. 9 and 0 is 9. 6 and 3 is 9. 3 and 6 is 9. 8 and 1 is 9, ... So if I do that subtraction, I'll end up with this. So 0.1036 and so forth. Oh, I apologize. I've just seen it's greater than 5, so I don't want it to be 5 either. I need to update this number to 5. It's daft on me, so I actually need to update that. That's all wrong. Let's just remove that and go back. I'm glad that I spotted that. Because it's bigger than 5, I don't want it to include 5 either. So that needs to be 5 there. Sorry. So I just go back here. And just going back in. I'll have to redo there. So it's going to be 0.96222 ... Again, same works. So first number to get 9 is 0. That one's a 3. Then I've got a 7. Another 7, another 7, ... So it's 0.03777, whatever that's going to be. In part C, let's just have a quick read. The officer will stop production if the number of defects in the sample is greater than a certain value D. Given that the officer stops production less than 5% of the time, find the smallest value of D. So we're looking for a value of D such that the probability of X being greater than whatever this value of D is less than is less than 0.05. So I want to know, when is this above D? Because I know that he stops at less than 5% of the time, which is 0.05. So I want to find the value such that when my random variable is bigger than D, that happens less than 0.05% of the time. So there's a few ways of kind of doing this. The first is simply to just start figuring out values in your calculator. So for example, if I put 4 into my calculator and just figure out what that actually gives, I did that a second ago actually, so I should remember. That gives me 0.8963. Because it's less than or equal to 4 here, what that implies is that the probability of X actually being bigger than 4 is 1 minus this. So 1 minus 0.89 is 0.1037 in this case. This is bigger than 0.05. I want to be less than 0.05, so it's not this one. If I try 5, so if I do X is less than or equal to 5, that's equal to, and we did it here actually, so I'm going to copy that value straight from here. So it's 0.9622, which implies that the probability that X is greater than 5 is equal to, let's just do that quickly. It's going to be, oh, well, I actually did that up here as well, didn't I? It's going to be 0.0377. I don't know that last number actually, so I'm not going to write that. I do know it's an 8 here though, so let's write that one. There we go. So 0.0378. This value is less than 0.05, and that's the first value that is. 4 was too big. 5 is now less. So that's our value of D. So D is 5 in this case. As that's the smallest value of D such that this is true. That's one way of doing this. The other way to do it is, again, it's a little bit of using your calculator. So if I just rub out this for now, it's just readjusting this formula based on everything we've done so far. So I think the way that I've just done it is possibly the simplest way, but there is a way to just readjust this formula. So keep in mind on here, sorry, I should go back. Keep in mind on here that X is bigger than D. That's the same. So if it's greater than D, that's the same as 1 minus the probability of X being less than or equal to D. And I want to know when that's less than 0.05. If you rearrange this, so if I take away 1 from both sides, and then I adjust for the minus. So if I take away 1 from both sides, I get minus P, X less than or equal to D is less than minus 0.95. And then correcting for the minuses, Px is less than or equal to D. And when you divide through by a negative, it changes this inequality. So now I'm looking for the first number of D such that it gets bigger than 0.95. So when I put D in there of 4, this number here is less than 0.95. So I know I need to go bigger. If I put 5 in, this number is bigger than 0.95. So I therefore know my answer is D. So from this, I can just say the probability of X less than or equal to 5 is 0.96222, which is greater than 0.95. And then therefore D equals 5. So that's another way of doing that, another quick correction for you. So hopefully one of those methods helps. Again, you can use either calculator here. I didn't actually give the graphic calculator a look in at this point, but you can use either for that particular method. But hopefully that helps.